Any TypeScript fans in the audience? Yes, there's even some cheering. I love that. I started using TypeScript when I started contributing to our web open source project, and this is such a complicated project that I don't think I would be able to really contribute and maintain it without it being TypeScript. And since then, I've pretty much said bye-bye to JavaScript and moved everything that we have over to TypeScript as well. And I feel much more secure at night. I can sleep at night. I don't have to write endless unit tests to make sure that the code actually works. And I feel a lot better about the code that I have and then the code that the project has as well. Our next speaker, though, I fear is going to tell us that I've been telling myself lies all the time, and that actually, no, it's not very secure. That's what I think he's going to tell us. What he's actually going to tell us, we're going to find out in a second. I'm scared. I hope that I've been sleeping well for the last couple of weeks, because I fear I won't be for the next couple. He is the senior product architect at Dynatrace. He's the author of TypeScript in 50 Lessons, the TypeScript Cookbook, and also the organizer of a number of conferences. He's been an amateur theater performer for the last 30 years. And for those of you that think it's a little bit scary being up here on stage, he still has stage fright being up here. So yeah, it makes us feel a bit better about ourselves, right? Now, he did a short stint and created a pretty popular literature podcast, and building the website for that brought him back into web development. So please, raise the roof for the amazing, the wonderful, the magnificent Stefan Baumgartner.
Jesus Christ. Welcome everybody. Thank you for coming to my talk. My talk is called Lies We Tell Ourselves as Developers. Okay, better, much better. So, anybody in here using TypeScript, by the way? Yeah? Oh, wow, quite a bunch. Oh, I'm sorry. This is not going to be fun for you. I fear I will crush your dreams and destroy your hopes. So, I've written 2 books on TypeScript. One is coming out in our book. I show an example like this. This is a JavaScript example that parses. It doesn't error at runtime. It just doesn't produce any results. And TypeScript tells me that there are 10 errors in it. And this is fantastic. This is what TypeScript is here for. So those are the good things about TypeScript. But I'm not here for that today. Today, I'm going to show you the exact opposite. This is some code that comes straight out of an SDK that TypeScript is totally happy with. But none of those lines really work. You know, this thing will throw at runtime. You know, those types that, those things that TypeScript is supposed to find, those things that TypeScript is supposed to prevent us from. Let's go through it step by step. So we start with a function head, nothing that special. When we enter the literal key species, we return species. If we enter the literal key people, we return people. Function overload in TypeScript. Some of you have seen that already. Then we fetch something from the Star Wars API. It's a great way to test your things. And since this JSON parsing might throw an error, we are catching the error and throwing another error, or maybe you do some mitigation there, whatever. This is the first function. The second function is called append entries. We are taking two arrays, concatenate them, merge them, and be done with it. And finally, we are calling it. We are creating a people array, and then we are calling append entries when we want to list entries from the type species. So that's pretty much a standard TypeScript fare. It's about 10 lines of code. Yeah, I formatted a little bit, but it's 10 lines. So what should go wrong? Ask yourselves, what could go wrong? I would say everything. Where does it go wrong? Everywhere. How does it go wrong? One by one, because we're single-threaded. That brings me to my most favorite JavaScript joke. Knock, knock, race condition. Who's there? Alrighty, but let's go through the problems. Start with the first chapter, a tale of fetch. Let's look at the core of the first function again. What I'm doing here is I fetch something from the API, and then I assign the result to a binding called data, which is of type meta people. And there's one little damned lie hidden in this statement. And the lie is that this only works, this let data meta people only works because the interface of the result of the JSON function returns any. And any is the happy-go-lucky type in TypeScript. It says, well, TypeScript tells you, go for it. Do you know what's best. Do whatever you think you should do. Because TypeScript doesn't know what's coming back. TypeScript only knows everything that can come back here can be anything. And you as a developer need to check what's going on there. And this is TypeScript at its boundaries. You know, everywhere where you have I/O, either calling something from a backend or having user input or anything like that, TypeScript tells you any, and you need to check if everything is okay. The problem is that this is the default. Nothing in TypeScript prevents you from doing stuff like that. And from that moment on, data becomes of meta people, and TypeScript assumes that everything is okay. We can mitigate this problem. There's a little thing in TypeScript called declaration merging. No interface in TypeScript is closed by default. You can always extend it and say, for example, let's open body again, open the JSON method again, and use the cautious type unknown instead of any. You can do that. You can patch it yourself. And unknown doesn't allow you to do things like that. With unknown, you need to make extra steps or TypeScript won't let you compile. So if I'm having this little patch and I'm calling the same function, I'm getting an error here. I'm getting an error here that unknown is not assignable to meta of people. You need to make sure that this works. First problem, first solution. Second one. The theme is dark and full of errors. Let's look at this syntax error here. That's curious, you know, we are catching an error. Result.json can throw an error if you're not getting JSON back. Well, then it's a syntax error. But the developer did add any to the mix. So why is that? I don't know if you ever dealt with error handling in JavaScript, but basically in JavaScript, everything can throw. All the time. You can throw an error, you can throw the number 2, you can throw undefined, you can throw everything, you can throw tantrums. Fantastic. So JavaScript is like my 2-year-old. My 2-year-old throws tantrums and I don't know where they're coming from, and JavaScript throws errors and I don't know where they're coming from. And since everything can throw in JavaScript, the developer was right to add any to the mix, because yeah, it's just like that. Either it's a syntax error or it's any other error. Everything can happen, anything can happen. The problem is that if you add a syntax error or any to the mix, the whole type becomes any, which means that you are, again, the happy-go-lucky type, everything can happen, use it at your own risk, you know best, you know what to do. We have a mitigation for that as well. Again, unknown, the other type, the cautious sibling of any, and we can activate unknown through a compiler flag. Fantastic. The next problem, solved, so we add unknown to it, either explicitly or through the compiler flag, and then do instance of checks for our errors so we know what's happening there. Instance of check, just like in Java, you check if this particular value is an instance of a particular class. Cool. Problem number 3. There's a lot of problems for 10 lines of code, isn't it? Let's look at the function head that we had earlier. We are using function overloads here. So the function overloads tells us for species, we get species. For people, we get people. But in the code, we only return people. So in the head, we are going for species. But in the code, we only return people. I don't know about you, but it gives me goosebumps right here on stage, and nothing prevents us from doing that. Again, this is TypeScript. This is function overloads. You have those function overloads here, but they mean something. You can split them up into 2 parts. Part number 1 is the usage part. This is the API that you give to your users. These are the calls that you can make. You can either call for species or you can call for people. And the last part is the implementation part. And the implementation part is, the one thing that you work against. So TypeScript does 2 things. It checks if your function body matches with the types of the implementation part. So if your function body just returns people, well, then it's okay with array of people or species because it's a subtype, it works. And then TypeScript checks if all the overloads are somehow handled with the function signature below. But nothing, absolutely nothing, keeps you from returning anything there, any bulk-up, as long as it works with the one implementation signature. You have the responsibility to check if the overloads are still be taken care of. You can add as many overloads as you like. If you're not returning it, well, too bad for you. It's another mitigation for that, thankfully. I use a conditional type. This is very interesting. Conditional types, I don't know if you've used them already, but they work basically like ternary operators, like if-else conditions on a type level. So I can check if the type that I'm getting in, the type, not the value, is the literal key species, then I return species. Otherwise, I return people. And if it's something that I don't know at all, I return never. So a situation that can never happen. It's a very complex type, but it gives us a very similar API to what we had with the function overloads, which means I can write something like this. I have list entries, and instead of having lots of overloads, I just have this one particular conditional type there, and it tells me the same thing. The good thing about this is that this conditional type is pretty complex, and TypeScript can't resolve the type within your function body, which means that you get an error, which means that TypeScript requests you to do something, to double check and triple check if your types are still okay. And this is what we are here for. You might say, oh, there's an error, but actually that's what TypeScript is all about. TypeScript is about showing us errors if something goes wrong. And now we found a way to see, well, something might go wrong. The 4th problem, and this is potentially my most favorite one. Yeah, I call it the unexpected verge of ignorance. If you know the movie where this is coming from, please find me after the talk. The first function already had 3 problems, and the second function has just 1 line of code and also a very big problem. So I take append entries with a list that can be either people or species, and I attach a list to it that can be also of people or species. Then I create the list, which is of type people array. And then I call append entries with list and list entries, where I request species. So I would expect to concatenate people and species. This is what I'm supposed to connect. What's the type of list after append entries? Any guesses? It's still people. Nothing changed. It's still the same type. TypeScript. Oh, sorry, yeah. I'm not supposed to curse on stage, so I give you the emojis there. The problem is here that TypeScript doesn't know anything about mutability. TypeScript doesn't know that the type will change once you call append entries. And it's obviously also because I use the push function and not something like concat, which gives you a result back. So I'm mutating the first element, but TypeScript has no way of telling me that those things have changed. For TypeScript, all the contracts are fulfilled. Everything has been checked against. But in reality, stuff gets mutated. And you can argue this shouldn't happen in JavaScript. Why does it happen in TypeScript? There is no way of expressing that right now. One mitigation for that is adding generics. So instead of having a very broad type, I'm having T, which extends this very broad type, and I use that instead. And over here. And the good thing about this is the moment I call append entries with list, this T gets locked down to the actual type of people array, which means that also the other T is now a promise of people. And I'm getting an error. You know, the things that should happen. And it tells me that I can't combine species or people. All right. I've shown you 4 lies of TypeScript and 4 solutions. Let's go to the final chapter. I call it lies, damn lies in TypeScript. The story so far, we have found 4 problems and 4 solutions. We were using declaration merging to patch our assumptions. It shouldn't be any, it should be unknown. We are doing instance of checks and unknown for error clauses so that we can make sure that it's actually the one error that we are looking for. We use conditional types instead of function overloads to highlight unsafe operations. Fantastic, now we need to do something. Now we need to check if our type set up. And we can use generics to narrow down to specifics. Yeah, and I'm very sorry. I just told you more lies. Actually, every one of those solutions comes with another lie. Here I'm having an interface form data, and I just add address and name to it. But once I use it, look at it. I'm having this get method. Where is this coming from? Where does this get method come from? And if you look at it, you have other methods as well. You have about 6 or 7 more methods in your form data. Where is this coming from? Well, it comes from the interface form data. You know, you can open up every interface, and if you don't know that form data exists in the global space, guess what? You are extending a global interface. And you know, if you're handling forms a lot, you might write an interface called form data. So declaration merging is great unless you accidentally merge with globals. And this is not something that I came up with. This is something that I see a lot of people do. And somebody on Twitter, or X, was telling me that, you know, I saw your talk and finally they were able to mitigate this problem. The next slide, this is beautiful. I'm having 2 classes here. I'm having class A with A of number and class B with B of number. And I'm having this do something function there. I'm doing instance of checks. I'm getting either A or B, and if it's an instance of A, fantastic, then do something with the A property. If it's an instance of B, then please do something with the B property. Brilliant. The problem is that TypeScript has a structural type system, which means that I can pass any literal there that has the same shape as an instance, and TypeScript says, fantastic, that checks out. It's the right thing. So it checks out, it type checks, but it's not an instance of A. So the instance of check won't recognize it as an instance because it hasn't been created from the A class, which means I run into the B branch. And yeah, here I'm logging undefined, but what if you do something with that number? That crashes at runtime. You know, that's stuff that TypeScript is supposed to prevent. So yeah, instance of checks are great unless you realize that TypeScript is structurally typed. What was the next one? Conditional types? Yeah. From the producers of regular expressions comes the sequel nobody asked for. No, seriously. Anybody sees at a glance what this is supposed to do? I don't. And I wrote this. That's my code up there. I have no clue what's happening there. I mean, I could derive it from, you know, query it, remove, I don't know, overloads. Yes, something type blah, blah. But in reality, this needs documentation. This needs tests. This needs something that documents its behavior, because nobody can parse it quickly and understand what's going on there. If you get something like that in a pull request, good luck. Oh yeah, shameless plug, buy my book, there's an explanation for that. But the thing is, conditional types are great and they are powerful, but they require you to take extra care. And last but not least, generics. Yeah, generics are great if you don't rely on explicit instantiation. Because I can just say, you know, I'm supposed to add people and species there, and then you have the same problem as before. And lots of people do that. Lots of people add explicit types to generics, which is something that you can do, but I would discourage. Yeah, all right. It's now for the last chapter. Again, I'm very sorry. This wasn't a fun talk. I showed you 4 problems. I showed you 4 mitigations. And in the end, I showed you 4 more problems. And I guess I can find mitigations to that as well, but guess what? I'm pretty sure it's just more problems. And you might ask yourself, after you see me doing this, I'm doing workshops on TypeScript, I'm doing books on TypeScript, what do I think of TypeScript after seeing so painfully obvious problems? Yeah, I fucking love TypeScript. No, seriously, it's the second best programming language that I had the pleasure to work with. And it makes me productive. Nobody can argue against it. TypeScript makes you productive. This is what TypeScript is all about. It gives you intelligence, it gives you types, it gives you information on your code. Your code becomes more arguable. If you see a pull request and you see a type tag, you understand what's going on there. Beautiful. If you communicate with your team based on types, things get better. And you know, this talk is not called The Lies TypeScript Tells Us. This talk is called The Lies We Tell Ourselves as Developers. And there are plenty of those lies. One lie is that we think that our tools are infallible. Another lie is that we think that we are here to code. We are not here to code. We are not here to write programs. We are here to make decisions. Software engineering is all about decisions. Every line of code that you write, or every line of code that you snuck from Copilot or wherever, and put in your code base, is a decision that you made. Every tool that you use is a decision that you make. And if you're using those lines, or if you're using those tools, you need to be aware of the trade-offs it comes with. Do you know who knows a lot about trade-offs? The TypeScript team. This is an excerpt that comes from the wiki page. The wiki page has a list of non-goals, and one of that is, and I quote, they don't want to apply a sound or provably correct type system. It's kind of weird for a type system, isn't it? But instead, they want to strike a balance between correctness and productivity, which means they are confronted with a lot of edge cases. Why are they confronted with a lot of edge cases? Because TypeScript lies upon JavaScript and to deal with the antics of JavaScript. And I don't know if you still remember a programming language or a type system called Flow. Anybody? Yeah, a few. Flow had a different trade-off. They said, no, we're not allowing every JavaScript to write. We rather say we want to have a provably sound type system. And this ultimately also led to the downfall of Flow. TypeScript was so massively adopted by developers because it made this particular trade-off. They didn't want to get into the way of existing JavaScript code. They didn't want to get in the way of the things that developers write. And this is a conscious decision that they made, and a conscious trade-off that they are willing to take. And this is also the thing that we are supposed to do, because we are all developers. Seriously? I was building up to that moment. It is our duty. It is our duty to make sure that the tools we choose and the decisions that we make work for us in our team. You are not coding alone. You're either coding, I don't know, with you and your future self, or with a group of people. And everything that you decide to put in your code base should be agreed upon with your team and the people that you need to work with. And this is a group effort. There's a beautiful paper by Peter Nau, who says that type systems are actually only here to create a language between people to communicate about their software. That's its goal. It's there not for a type checker to see that your code is correct. It's there for you as a group to see, to have a basis of common understanding, a basis where you can write programs together. And you know, I mean, I now kind of bitched a little bit about TypeScript, even though I love it. Love it from the deepest of my heart. And we as developers love to bitch about programming languages. We try to make fun about it. So one programming language that gets laughed upon is PHP. And you know, there's this infamous photo of Taylor Otwell, who created the Laravel framework, who shows off his PHP Lamborghini because PHP paid for it. And then you have the Java Fiat in Austria. That's a real car, you know? So yeah, take whatever you think about it. But if you have 3 kids and a couple of groceries that you get from the store and a couple of crates of beer, which one does the job? Yeah, and I'm not here to tell you what you need to do. I just want to tell you that you need to be aware of your program. Don't take anything for granted. Be skeptic, be aware. You know, we live for those 5-minute hot takes that are on YouTube that tell you, you do the things like this, or please do things like that. And that's not what it's all about. It's about being aware. It's about being pragmatic. Choose what's right for you. Choose what's right for your team. And please teach any dogmatic advice. And yes, I'm very much aware that this is also dogmatic advice, but, you know, beat me. If you like to make decisions, come to us at Dynatrace, talk to us. We are doing this every day. I'm actually having 2 TypeScript and 50 lessons books with me that need to find an owner. I will be at the Dynatrace booth from 1 to 2 p.m. And with that, I want to say thank you very much for having me. Thank you very much for being at WeAreDevelopers.
Thank you. Thank you so much. There's quite a few questions, and a lot of people have the same one. So I'm gonna handle all of them. So Nicholas and Stefan ask what if TypeScript is your second favorite. What's your favorite? And then Xavier adds that before you answer. Yeah. Xavier says, "What is your favorite language, and why is it Rust?"
Who was that? Oh boy,
that's Xavier.
Okay, Xavier, Xavier, you know me. It is actually Rust. So yeah. That's the second applause, isn't it? It's Rust. Yeah. So the thing is, I fell in love with Rust during the pandemic, and I'm still in the honeymoon phase. So after 3 years, it's still some big love. Though I know about the antics of Rust as well. So don't mistake me, it has its antics, but it's beautiful. Guess what my car looks like?
Yeah, I'm not going to answer that. Ringo continues down that route, and he says, would it be better to just use Rust instead of TypeScript and transpile that to JavaScript?
Oh no, so the thing is, every tool for its job, and I think TypeScript is beautiful in the browser. I don't want to work with Rust in the browser. I want to write browsers in Rust, but I don't want to work with Rust in the browser. And also, you know, if I have a couple of little serverless snippets, I also write them in JavaScript. There's a tool for each job, even do some Python nowadays, so yeah.
Excellent. And I'm wondering if you have an alternative to instance of. I effing hate instance of. I do a lot of cross iframe, and then if you do instance of HTML element, of course it's a different window. Anyway, I hate it. So I wonder if you have anything else that you like to gravitate towards instead of instance of.
Instead of instance of.
Yeah.
So there's always. So the thing is, especially with TypeScript, instance of is the only check that you can reasonably do at runtime.
Yeah.
And this. You know, this doesn't work out if you don't use classes like I do. Then you're stripped away of one beautiful thing that you can check at types with. But if I would to do type checks at runtime, I'm using Sodalot. It's a beautiful library. It is very much inspired from TypeScript, which means that you can align those types really, really well. But you get runtime information. You can check your things. So it makes sense not only if you take elements from a backend or communicate between iframes or so. Yeah. It makes really sense if you really need to have type information at runtime and get those nice little nuances like, well, this should be a number, but it should be between 0 and 99. Right. And this should be a URL. Please do a proper URL check. That's beautiful stuff. I like that a lot.
I like that. The first when I saw the .json, the first thing that went to my mind was like, Zod would be a good
Yep.
fix for this as well. So awesome. Last question. You mentioned that every tool you use comes with its own trade-offs and is a decision. What do you think of Total TypeScript's TS Reset? Do you know about it?
I know about TS Reset. It's done by Matt Pocock, and it's a beautiful library. It goes a lot into the problems that I've shown here. I would definitely recommend something like that. But again, it comes with its own trade-offs because you're suddenly changing behavior that is maybe required from libraries that you use. So be aware of the trade-off, but either pick little snippets from it or use it as a library as a whole. But it's a beautiful library, there's even lots of extra stuff in there that I can highly recommend, Also things like ESLint gives you tips on those things as well, since it has TypeScript integrated since recently by Josh Goldberg, beautiful guy, and does a lot of great work in the TypeScript era. So
and you absolutely can't use TS Reset if you have your own library, because that's gonna mess with everybody. Thank you so much. That was absolutely great. Give him another round of applause. Thank you so much.
Bye.
All right, up next in 10 minutes, we're going to be talking about going from punch cards to AI-assisted development. Quite a big leap, I would say. See you there in 10 minutes, and if I don't, have a great day. Cheers.